Okay, so in my earlier video, already I finished over here. Because of space problem, I could not finish the other steps. Here you just see that you can easily view that in the step 6 we have done R1 is equal to R1 minus 2R2, and this is 1 0 minus 1 by 3 already I explained. From here I turn these two steps. From step 5 I got this step 6 using these operations, and hence using this 1 I have made this as 0 as I explained. Now in step 7 my next target is that this A32, that is second column of the third row, this part should be 0. Whenever I am doing this, which instructions I will follow? R3 is equal to R3 plus 5R2. So if I do R3 is equal to R3, I want to perform here. R3 is equal to R3 plus 5R2. So 5 into 0, 0. So it is 0. This is also unchanged. This is 25 by 3. So minus 8 plus 25 by 3, I got 1 by 3. This is 1 by 3. And the same operations I will also follow in the right hand side. This was 0. 5 by 3 plus 0 is equal to 5 by 3. And 5 by 3 minus 3 should be minus 4 by 3. And this is 0. So naturally this is 1. So this step 7 we have understood. And in this way we are able to change the second column as 1. Then using this 1 we have made these two 0. Now 1, this is 0. My next target will be to, along this principal diagonal, this has to be made 1. See, I have no other options. So naturally, I have to go with the third option, that is scalar product, eliminating operations. If I multiply this R3 row, entire R3 row by 3, this is 3R3, I can turn into 1. So I made R3 is equal to 3R3, because 3 by 3 is equal to 1. Now, so this part I have changed into 1, and the same operation also I have done over here. That is, this was 5 by 3. If I multiply this by 3, I get 5. If I multiply this minus 4 by 3 into 3, I get minus 4. And this 3 into 1, 3. So I think that we have able to understand this step 8 using this R3 is equal to 3R3. Very easy operations. Our objective is to make it 1. Because if I can similar like the previous follow the previous one of the third column, I am able to make it 1. So my other work is very easy. Using this 1, I have to make these two bodies 0. So how I have done it? R1 is equal to R1 plus. So this R1 I have to change, and my target is to make it 0. How? R1 is equal to R3 by 3. What is R3? If I divide this by 3, 1 by 3, so 1 by 3 plus minus 1 by 3 is equal to 0. So this is, I got R1 is equal to R3 by 3, and I got this is as 1 0 0. This is 0 1 5 by 3. Same I have written, and this 0 0 1. So the step 9, in the step 9, I got the third column of the first row. First row of the third column. Now I got 0. That is A13 positions. I got it 0. Once it is 0, my last target is to make this 5 by 3 0. How I got it? By the way, same operation also I will do over here, because R1 is equal to R3 by 3. So 5 by 3. So 1 plus 5 by 3. Here 5 by 3 minus 2 by 3, I got 1. So naturally, same operations, whatever the operations I will do in the left hand side, the same operations I will do in the right hand side. This is the base bucko. That is the basic things that we have to follow on both sides. Now the last step, that is I have to convert this part as 0. Second row. That is R2 is equal to R2 minus 5 R3 by 3. R2 is this is your R2. This is your R2. So this R2, if I multiply this by 5, if I multiply this by minus 5 by 3, this will be 1, and hence using this 1, if I want to make it 0, then I have to write R2 is equal to R2 minus 5 by 3. Minus 5 by 3 plus 5 by 3 is equal to 0. So this is naturally becoming 0. The same operation also I will do over here. Here is your R2. So naturally this is your 5. If I multiply this by 5, this will be 25 by 3. And 1 by 3 minus 25 by 3, I got minus 8. And similarly 1 by 3, here also same things. Minus plus 20 by 3, I get 7. And this is 1, this will become 1. And ultimately I got this my target, this B. Whatever I said in my early lecture, this is my target and this is my inverse. And I got therefore that A inverse is equal to 1 minus 1 1 minus 1 1 minus 8 7 1 minus 8 7 1 and 0 0 1 and 5 minus 4 3 and 5 minus 4 3. And that is my operation, that is I got the inverse. Now the question is that how can you be sure that this will be your inverse? How can you check it in examination hall? If I rub this now, because of space problem I have to rub it, otherwise the board is very small. In future maybe that I'll use bigger board for better understanding. Now see that how can I understand that this is your A inverse. I am claiming that this is if A is the matrix, then the inverse is 1 minus 1 1 minus 8 7 1 5 minus 4 3. See, in examination hall there are so many processes to check it. I have also one of my very famous shortcut operations for finding the A inverse. That is very secret. I will tell you after 6 months, not now, because I want that now you should know the Martin's rules, or to practice it, and after that I will use my shortcut methods. But it is my own work. Now here to check this inverse, what you can do, this is your original matrix A. So if you multiply A inverse, this minus 1 1 2 1 2 3 and 3 1 1, and if you multiply this by this inverse 1 minus 1 1 minus 8 7 1 5 minus 4 3, if you can get this operation, you will get after this product you can get identity matrix. This is you are supposed to get. If you get, you can say that your operation is correct. If you don't get this identity matrix, then somewhere you have done mistakes. Then you have to check that why you have done the mistakes. So this is the entire row operation, and by row operations we have done. We have got this inverse. If you want to get the similar topic, you have to subscribe my channel. YouTube also you can get all my lectures one by one. I will be releasing this, but my institute name is Sumit School of Mathematics. Sumit School, in my name, Sumit School of Mathematics. My WhatsApp and phone number is 9433328434. Here either you can WhatsApp me or you can email also. My email is coffee1000@gmail.com, or in my institute also you can get admissions. Definitely, I don't teach my school students. The other students, they can come and join over here. Thank you very much. Have a nice day.